On page 7 of our Unit 4 notes, we are looking at the range of continuous relations. Now, rather than looking at what are the possible x values, left and right, we are looking at what are the possible y values, up and down. For these first two examples, we have a lower bound, a minimum y. So the minimum y here is negative 1, 2, 3, 4, negative 4. But because of that open dot, y cannot actually equal negative 4. Y can be anything greater than negative 4. So there's a point on this graph for every y value greater than negative 4. For this one, there's a point and actually 2 points on the graph for every y value greater than or equal to, since it's not an open dot, we assume a closed dot, every y greater than or equal to 1. So y equal to 4, there is a point on the graph. Upper bound here is y is equal to 4, but y can also be anything less than 4. There's a point on the graph for anything, any y value less than or equal to 4. Here we're looking at y less than or equal to 3. This is a little small. So kind of like we were looking at the x-axis, now we're looking at how much of the y-axis is taken up. Less than or equal to 3, less than or equal to 4. Greater than negative 4, greater than or equal to 1. Here we have an upper and a lower bound. We write the lower bound negative 1 and the upper bound of 1, 2, 3, 4, 5. There is a point on the graph for every y value in between negative 1 and 5. This is a weird one. We talked about this in class. We could write this as the compound inequality. Negative 2 is less than or equal to y is less than or equal to negative 2. It's a weird way to write it. There's only one value in the range. It's y equals negative 2. You could also write that with set notation. The only possible value for the range is negative 2. All real numbers here. The graph goes forever to negative infinity and forever up to positive infinity. This one too, it doesn't matter that there's a lower bound for x. We're looking at y. We go up forever, 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 up to positive infinity, forever, 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 down to negative infinity. I don't think there were any really weird ones on the practice page. This was just confusing for the domain, but the range is just y is greater than or equal to negative 1, negative 2, negative 3, negative 4. Y is greater than or equal to negative 4. Y, there is a point on the graph for every y value greater than or equal to negative 4. All real numbers. Negative 1 is less than or equal to y. Did we already do that one? No, just similar. And then here, the range is all real numbers. We go forever to positive infinity, forever to negative infinity.